In today's math lesson, we're going to write the variable expression for geometric sequences. Having been given a geometric sequence, if we have the sequence of values, we can then write the rule, the equation that they came from. That particular rule is a sub 1, the very first term, times the ratio of the first two terms to the power of n minus 1. So the first thing we need to fill this out is a sub 1. And a sub 1 is the value of the very first term in the sequence. The second thing you need is r. And r is the pattern that you need to get from step to step. And for a geometric sequence, that pattern comes from the ratio that you get by dividing the second term divided by the first term. And if it can reduce, yes, you do, but that's r. And there will be no further simplification as our variable is up in the exponent. So this is going to be a very quick and friendly lesson. In example 1, we're going to determine the equation to describe the sequence below of 2, 4, and 8. Knowing that our rule comes from the first term times the value of the ratio of the second and third terms, let's get started. So we know that the value of our very first term is 2. This is a sub 1. Let's go find r. r comes from our second term divided by our first term. So if a sub 1 is 2, that means that our second term, a sub 2, is equal to 4, because that's what comes next in the sequence. So 4, our second term, divided by 2, our first term, well, that just happens to be 2, and that's r. So now that I have my first term and my ratio r, let's go find out what we have. So a sub n is equal to the value of my first term, 2, times the ratio, which also happens to be a 2, to the power of n minus 1. No simplification needed, and there you go. In our second example, we're going to write the equation to best describe the sequence below of 1, 4, and 16. Knowing that our rule for this geometric sequence comes from the first term times the ratio between our second and first term to the power of n minus 1, let's see what we've got to get us started. So our first term is right here. It's a sub 1. So now all I need is r. And we remember that r comes from the second term divided by the first term. If 1 is our first term, then we quickly see that our second term has a value of 4. So our second term divided by our first term is 4 divided by 1, which is just 4. Okay. So now that I have my first term and my r, let's go use them. The geometric sequence that we have is going to be a sub 1, which is 1, times the quantity of r, which is 4, to the n minus 1 power. Now, as you know, it is unnecessary to have a 1 in front of a set of parentheses. So we can very nicely just barely simplify and clean this up to be 4 to the n minus 1 power. And there you go. In our third example, we are going to look for the equation to describe the sequence below of 5, 10, and 20. Knowing that a geometric sequence comes from the rule of the first term times the ratio of the second and the first term to the power of n minus 1. Let's get started. So we see from our geometric sequence given here that 5 is the value of our first term, a sub 1. Now all we need is r. R comes from the second term divided by the first term. Since 5 is our first term, then we see quickly that 10 is our second term, a sub 2. So our second term of 10 divided by our first term of 5 gives us an r of 2. So now that we have a sub 1 and we have r, let's go write our equation. A sub n is equal to the first term, which is 5, times our ratio of 2 to the power of n minus 1. And there is no simplification that can be done here at all. And there you go. In example 4, we're going to write the equation that best describes the sequence below of -1, +4, and -16. Knowing that our equation rule will come from a sub n equals our first term times the ratio of our second and first term, let's go get this party started. So our geometric sequence begins with a -1. This is our first term, a sub 1. So our r comes from the second term divided by the first term. And since -1 is a sub 1, it's our first term. That means that +4 is our second term. That's a sub 2. So we have 4 divided by -1, which gives us -4. And that's the r. Now that we know exactly what the first term and r happen to be, let's go write our equation. A sub n equals, the rule for this geometric sequence is -1 times the quantity of -4 to the power of n minus 1. Now in this particular rule, we cannot simplify these negatives. That is because the -4 has an exponent of -1, and the rules of operations tells us that we have to address exponential behavior before we handle multiplying behavior. So this is as far, really, as this can go. And there you go. In our fifth and final example, we're going to write the equation that describes the geometric sequence below of -1, 2, and -4. Knowing that geometric sequences can be written with the rule of the first term times the ratio of the second and first term to the power of n minus 1, let's get our numbers figured out. We see quickly that our first term is -1, so that's a sub 1. And r comes from the second term divided by our first term. Since the first term is -1, that means the second term is that 2. So as we build our ratio, that means I have 2 divided by -1, which gives us a result of -2 being r. So now that we know exactly what the first term is and what the r is, we can write our equation. A sub n is equal to the first term, which is -1, times the quantity of -2, our r, to the n minus 1 power. And we cannot simplify this because, as we stated in the previous example, a negative value inside of parentheses with an exponent has to be addressed in the order of operations before multiplying can be addressed. So this particular equation is as simplified as it can get, with -1 times -2 to the n minus 1. And there you go.